Hello, good morning.
Good morning, sir.
Okay, good morning, Charan. Good morning, Lokesh.
Good morning, sir.
Right. Okay, let's continue now. So we discussed about the how the resistance changes, है ना? What are the different factors on which the resistance of a conductor depends, isn't it?
Yes.
Okay, let's continue now. The next part. Right. So we were in this electric current part. Okay. So in the electric current, we have learned about the current different uh, properties, isn't it? That what are the factors on which the current is depending, isn't it? These are the things we have discussed in our yesterday's class. Okay, current density. How do we find out the current density? Okay, how the factors or what are the factors on which the resistance depend? Okay, let's say there is a question given to us. Okay, on the current density, there is a question given to us. The question gave what? That current density in a cylindrical wire, okay, cylindrical wire is given as J equal to J naught into 1 minus small r by capital R. Okay, what is the current density? J naught into 1 minus small r by capital R, where small r is what? Small r is the distance from axis, and capital R is what? Capital R is the radius of the cylinder. Okay. Look at this question and tell me, is it a uniform current density or variable current density? Check it. J equal to J naught 1 minus small r by capital R. So you see that as the distance from axis changes, the current density also changes. Okay. So this is an example of what? The variable current density. Okay. The current density in a cylindrical wire is given as this. Find total current flowing through the wire. Okay. Total current flowing through the wire. Okay. So tell me, how do we calculate the current from the current density? What is the relation between current and current density? Chaliye, please try this one and tell me what is the answer coming. Tell me what is the answer coming for this question. Current density is given in the problem, and from the current density, we have to calculate the current in the wire. How, how much is this coming? Are you trying this one? Please tell me. Please tell. Trying this one? See, current density is given to us and we want to calculate the current, and it is a variable current density. So can I say that current density will be, current will be equal to current density into area, isn't it? But here the current density is variable, so we cannot directly multiply current density into area. We have to do what? We have to first find out what is the current flowing through a small area, and then we have to integrate it to get the total current. Okay, and this is a cylindrical wire, na? This is what kind of wire? A cylindrical wire, isn't it? So what we did at a distance a small r, what we consider a small dr thickness. What is the current flowing through this a small area? So what will be current through this small area? The J means what? J naught into 1 minus small r by capital R. Okay, that is the current density given in the question. Okay, current density how much is given? J naught into 1 minus small r by capital R, and that small area through which we are calculating, that small area is going to be 2 pi r dr. Now let's simplify it, and for complete conductor what will be current? 0 to r integration we can do it. J naught outside, 2 pi outside, and next what we have? 1 into r into dr. So r dr integration will come r square by 2 minus 1 by capital R. Next we have r square dr. R square dr means r cube by 3, and we have kept the limit also there, isn't it? So this is what we have. Simplify it a little bit further. R, and here it will become r square. J naught 2 pi r square common, 1 by 2 minus 1 by 3, that is 6. 3 minus 2, that is 1. Okay, 2 and 3 will get cancelled out. J naught pi r square by 3. This is the current flowing through this conductor. Understood? So whenever we have to calculate current with the help of current density, what we will do? If current density is constant or uniform in the question, what we will do? We will just find out current density into area. If it is uniform current density, but if it is variable current density, then what we should do? We should first find out current through a small area and then integrate it to get the total current flowing through a cross section area. Understood? Clear? Up to this clear? Clear these things we have discussed. Now, the next one, resistance we have calculated. What is the resistance we have calculated? Resistance we have calculated as rho L by A, isn't it? Rho L by A. So let's discuss one example of resistance calculation. Okay, a hollow cylinder is given to us. Okay, a hollow cylinder is given to us. Hollow cylinder how? Like this. Okay, inner radius is r and outer radius is 2r. Okay, and this part is what? Hollow. This middle portion is what? Hollow. So if you connect it through the battery, what will happen? Current is only going to flow through this portion. Okay, right? And length of the cylinder is given as something L. Okay, so in this question they are asking find resistance of this hollow cylinder. Okay, find resistance of hollow cylinder. Okay, please tell me how much will be the resistance of this hollow cylinder. So how do we calculate it? So, and resistivity is rho given to us. So can we write it? Resistance of this hollow cylinder will be, resistance can be written as rho L by A, isn't it? The rho to no problem. Length of conductor also no problem. But when we will be writing area here, so area means what? Area means the cross section through which the current is flowing. So here middle portion is hollow. So current is flowing through what cross section area? Pi into 2r square minus pi into r square, isn't it? Because that pi r square area, that is hollow, na? There is no current flowing through that one. Understood? So that's why that area we have subtracted here. So rho L divided by pi into 4 and 1. So 3 pi r square we are getting. Okay. So sometime we have to only use the effectively what area through which the current is flowing. Okay. If current is not flowing through the complete area, some part is hollow. So we should subtract that hollow area whenever we are calculating the resistance of a given conductor. Please tell, clear up to this? Tell me, clear up to this?
Yes, sir.
Right. Now, let's discuss an example here. In this example, what is given to us? A conductor is given to us, okay? And the conductor is in the shape of like this. Can you see the radius of conductor is changing as we go from one end to another end, isn't it? And current is flowing like this. Okay. So in the question gave, the diameter of the conductor is given as d equal to d naught 1 plus something kx given to us. See that is the, and x is what? X equal to 0 is this one. X equal to 0 is this one. And total length of conductor is x equal to L. 0 to x equal to L. So as you are going from one end to other end, what you are seeing as we go from one end to other end, you see the diameter of the rod, diameter of the conductor is changing. Understood? Diameter of the rod is what, or diameter of conductor is what? Changing. Okay. And current is going to flow which direction? Current is flowing in this direction. Along axially, the current is flowing in the conductor. Okay. L is the length of conductor. Resistivity is uniform. Okay. In the question given, resistivity is uniform in this question. Okay. So now they are asking in the question, find the resistance of this conductor. Okay. Find the resistance of the conductor given in this diagram. Okay. So chaliye, please tell me. Okay. Now here, if you write it resistance, what you will do it? You will find the resistance, isn't it? But you cannot apply directly rho L by A. Why we can't apply rho L by A? Because the problem is area is continuously changing, isn't it? Area of cross section of this conductor is what? Is continuously changing, isn't it? So it means I cannot apply resistance equal to rho L by A. Because if area is changing, what area I will use it, isn't it? So that is the problem we have. So chaliye, tell me what we should do it in this question. How do we calculate the resistance of this conductor? Chaliye, try it and tell me what is the answer coming. Please tell me how much is this coming? What is the resistance coming? Whenever something becomes a variable, we should take help of what? The integration, isn't it? Whenever something becomes a variable, what we should do? We should take help of what? The integration method. Okay. Chali, use the integration method and find out the resistance of the conductor. What is variable in this question? In this question, resistance, we want to calculate it, and area of cross section of the conductor is what? Variable. In this question, what is given variable? Area of cross section is given as the variable. Okay. So please tell me how much is this coming? Tell me, children. Lokesh, are you trying this one or not?
Yes.
Okay. So chaliye try it. Let me give you a hint. What you should do it. Can I consider at a distance x? Can I consider a, a small cross section of what length? Of dx length. First, I will calculate what is the resistance offered by this small portion, isn't it? And like that, all these next portion, isn't it all are connected in series? You see that? All of them are connected in what? It is connected in the series. Understood? So that's why if you want to calculate the total resistance, we should add all the resistance, isn't it? Because series, R equivalent is what in series? R equivalent in the series is R1 plus R2 plus R3 plus R4. So all these small resistance of this conductor is connected in series. So we can add them, isn't it? So first of all, tell me what is the small resistance of this part? A small resistance, if I want to calculate dr, how much it will come? Rho length. Length is dx. Area. What is area? Pi by 4 into diameter square. What is the diameter of that section? So diameter is changing at a distance x. What is the diameter? D naught into 1 plus kx. Please tell me, is this part clear? Is it the small resistance clearly written? Resistance of small, that blue section we have considered in the conductor. This is the resistance of that small section. Now if I want the total resistance and all these sections are connected in series, so we will write it what? dr plus dr plus dr plus dr. So series, when you are going to add it all of them, dr plus dr, the total resistance will become what? The sum of all these dr, isn't it? Just add it. Add it, then what will happen? Rho dx divided by pi by 4. This one will become d naught squared, and we have 1 plus kx whole square. This integration we have to do it, and x will change from where to where? 0 to L. And the total length of the conductor is L. So x will change from 0 to L. Rho is constant, 4 is constant, pi constant, d naught square constant. We have integration of dx by 1 plus kx square, right? It's simple integration. 1 plus kx we can consider is at what? Z, isn't it? 1 plus kx we can consider it as what? Z, right? So k into dx will become what? Dz, isn't it? So dx will become dz by k. So if you integrate it, what it is coming? 4 rho pi d naught square. And if you consider 1 plus kx as something z, so if you differentiate it, k, है ना? dz by d by dx you are doing. So that is 0 k into 1 dz by dx. So k dx equal to dz. So this integration will be get converted into what? This integration will be converted into dz 1 by k dz and 1 plus kx, that is z square. So just integrate it 4 rho pi d naught square k outside and dz by z square integration. So z to the power minus 2 plus 1. Minus 1 by z will come, right? So minus 1 by z means what? 1 plus kx will come. Now let's put it the upper limit and lower limit, okay? So what are we getting? 4 rho by k pi d naught square. If you put the limit, upper limit, if you put it, it will become minus 1 by 1 plus kl minus Lower limit, if you put it, so minus 1 by 1 plus k into 0 to 1. Right, that's it. If we can simplify it further, 4 rho k pi d naught square, है ना, 1 minus 1 by 1 plus k l. Further simplification can be done na, after taking LCM. We can take LCM and we can do the further simplification. So please keep in mind whenever we want to calculate the resistance of a conductor, right? We will use it resistance equal to rho L by A only we will use it. But when we are using that equation, we have to make sure that is the area is constant, is the length is constant, or is it changing? If it is constant, no problem. Rho into L by A, we can use it as we have done it in the earlier cases. But in this question, what happened? As we went from one section to other section, we found out that area of cross section was changing, isn't it? So if area of cross section is changing, then we had no choice. We have to take help of what? Integration to calculate the resistance. Understood? Let's do one last example on this resistance calculation. Okay, using the integration method. In this example, what is given? A sphere is given to us. Okay, this is inner sphere and this is what? Outer sphere. Okay, and here the thing is what? Let's say this is the R and this is what? The 2R. Here the current is flowing like this. Understood? Means we have connected a battery in such a way that inner conductor is at high potential, outer conductor is at low potential. Okay, so how the current will flow? Current will flow radially in the sphere. Okay, this is a sphere. Okay, not circle. This is what? A sphere, hollow sphere of radius, hollow sphere of inner radius r, and outer radius 2r. Okay, inner radius r and outer radius 2r. Okay, clear? Now they are asking if a battery is connected, you know, it is a resistance calculation only, because if I know the resistance, I can find out the potential difference by resistance is going to be the current. Okay, so actually it is a resistance question only, but sometimes you will find it like this given. If a battery of EMF, battery of EMF E is connected, across inner and outer sphere, then find the current flowing through it. Then find the current flowing through the sphere. Okay, current flowing through the sphere. Okay, actually, please tell me how much it will be coming. So if you want to calculate the current, you need what? EMF. Okay, that is given. You need what? Resistance, isn't it? Actually, let's first calculate it. What is the resistance of this conductor between inner and outer spherical part? Okay, between inner and outer spherical part, what is the resistance of this conductor coming? Actually, please calculate that one first. How much is this coming between the inner and outer part? Tell me. Please tell me how much is that coming? How much is this coming? Tell me. Are you calculating? How we will calculate this one? Again, what we should do it? We should consider a small element. Okay. Here, the small element I will consider. Is that going to be also a spherical in nature? Isn't it? This is also going to be a spherical in nature. So what I did, I consider at a distance a small r, I consider a small thickness of dr. So first I will calculate what is the resistance of this small segment. Okay. Why? Because as we go from inner to outer surface, what will change in this conductor? Isn't it again the area will change? So that's why different area is coming at a different point. So first I will calculate what is the resistance of this a small segment I have calculated. The small segment resistance dr will come. Will it come rho length of a small segment dx and area of a small segment is what? 4 pi x squared. Please think it carefully. Is it the area of that element we have considered? Is the area of that element is 4 pi r square. Now we have considered r dr. If you consider x dx, then these things you will write it. Okay. So what it will come? Rho. It will come rho. What is the small length? dr. And what is the small? What is the area of that element? 4 pi r square. So this is the resistance of what? The small part we have considered. Okay. If we want the total resistance, all these small dr, all these layers are what? One over another. That means a series connection. Connection of resistance. What happened? R equivalent comes as R1 plus R2 plus R3. R equivalent will become R1, R2, R3. So if you have to add all these small dr, can I say that the R equivalent comes integration of that dr? Actually, let's do it. Rho dr 4 pi r square. Inner radius is r, outer radius is what? 2r. Simplify it. Let's see how much we are getting. Rho 4 pi common. Dr by r square integration minus 1 by r. Limit is r and 2r. Rho 4 pi. And if you put the limit minus 1 by 2r, and upper limit minus 1 by r, the lower limit. Okay. Rho 4 pi 1 by r minus 1 by 2r. That will come 1 by 2r. So what is the r equivalent we are getting? Rho by 8 pi r we are getting. Okay. So that is the resistance. Okay. This is the resistance of the conductor. How much is the resistance of conductor? Rho by 8 pi r. So what will be current flowing in the conductor? The current flowing will be EMF divided by resistance, isn't it? EMF divided by resistance. So E divided by rho and 8 pi r. That is the current flowing through this given spherical conductor. Is that clear? So please keep in mind how to calculate the resistance. Okay. How do we calculate the resistance? So definition of resistance says that resistance will be equal to rho L by A. If everything is constant in the question, just write it rho L by A. But sometime area will be changing. Sometime in the question, rho will be also given variable, isn't it? It's possible in the question that sometimes rho is also given as the variable. Like as we go away from the inner sphere towards outer sphere, the density is a change. Sorry, resistivity is changing. So that is also possible. But please keep in mind what is the resistance or what is the resistivity. Okay, resistivity means rho L by A. Okay, so if something variables come in the equation, what we should do? We should first calculate it for a small part of that object. Okay, and then we should integrate it to get the total value of the that particular quantity we are calculating in the question. Is that clear? So this is about the microscopic view, or this is you call it as the total resistance calculation of different shape. Okay. Next is when we are going to connect this resistance. है ना? What are the symbol of resistance? Symbol of battery. The battery symbol is what? Battery symbol is something like this, isn't it? Right? We have used it many times already in the question, isn't it? This bigger line is representing positive terminal, smaller line is representing what? The negative terminal, isn't it? So this is battery symbol, resistance symbol. Okay. So just like what we have done, the combination of battery, combination of capacitor, here two new things are going to come: combination of resistor and combination of cell also. Combination of resistor and combination of the cell also. Okay. So chaliye, let's discuss about these two topic now. Combination of resistance. Okay. Combination of resistance, again it means what? How many combination are possible? Two combinations are possible, isn't it? Series combination, and the next one is going to be what? The parallel combination. Series means what? What will remain same, or what will be same, so that I can say the series combination is given in the question? If current is flowing same in both the resistor, or two or more than two resistors. Okay. If two or more than two resistors involved has the same current flowing through it, then we will call what? These two resistors are connected in series. And what should be same for parallel combination? If potential difference is same, है ना? If two or more than two resistors having same potential difference across it, then what we will call? We'll call them, they are connected in parallel to each other. Okay. So what we got, the series formula and parallel formula of the resistor. So series means what? Let's say this is the resistance symbol, है ना? This is the symbol of what? The resistance, right? Like that, let's say there are many resistance given in the question, and that is connected through a battery like this. You see, whenever the current will flow through the battery, the same current is going to flow through all of them, isn't it? So that's why here we will call this R1, this R2, this R3. These R1, R2, R3 are connected in what? These R1, R2, R3 are connected in series to each other. So what is the R equivalent will come? The R equivalent will come R1 plus R2 plus R3 plus R4, like that. Okay. So that is called the series combination. Okay. So in series combination of resistor, please keep in mind when we discussed about the capacitor, series and parallel, we got opposite formula. Then what? Then the capacitor formula. So capacitor and resistor, you will find series and parallel formula is opposite of each other, but the concept is same. For series, current should be same. In case of resistor, in case of capacitor, for series, charge should be same. Same way for parallel, potential difference should be same in the resistor, and potential difference should be same in the capacitor also. Is that clear? Next one is the parallel combination. So in parallel combination, what is going to remain same? Potential difference across the different resistor is going to be what? Same, like this. We have connected in such a way that all of them are connected across what? Connected across the same potential difference. Let's say this is R1, this is R2, this is R3, like this. So here what is the parallel equation we will get it? 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3 like that. That is called the parallel combination of the resistors. So in the series and parallel, what happens? In series, current remains same. In the parallel, what remains same? Voltage difference or potential difference remains same. Understood? Now, sometimes different type of circuits are there. Okay, like some circuit will be given where it will be called the balanced V-tone bridge. What is the balanced V-tone bridge? So it is a combination of what? Series and parallel. But in that one, the value of resistors are given in such a way that it is called the balanced V-tone bridge. Okay. So what is the balanced V-tone bridge? Balanced V-tone bridge. So in the balanced V-tone bridge, what happened? And this balanced V-tone bridge condition, na, it's a very much important in solving many other question. In balanced V-tone bridge, what happened? Let's say this is the one resistance, this is the other resistance, this is the third resistance, and four resistance, and it is connected across a battery like this. Okay, this is R3, this is R4, and in between, what is connected here? Let's say there is R5 connected, or sometimes they will say a galvanometer is connected. Okay, अब if we maintain some particular value, है ना, if we maintain some particular value of this R1, R2, R3, R4, then what will happen? Then it will be called the bridge is in the balanced condition. This bridge is called as the balanced, Wheatstone bridge. So what is the condition required for balancing the Wheatstone bridge? The condition of balanced Wheatstone bridge is what? Condition of balanced Wheatstone bridge. Wheatstone bridge is what? That the condition of that one is what? If R1 by R2 is equal to R3 by R4. See, R1, R2 no need to be equal, or R3, R4 no need to be equal. But what should be equal? The ratio. R1 by R2 means these two resistance ratio. If it is exactly equal to R3 and R4 ratio, then that is called as what? That bridge is in the balanced condition. This Wheatstone bridge is what? It is in the balanced condition. Okay. So what is the condition of balanced stone bridge? Balanced Wheatstone bridge. If R1 by R2 equal to R3 by R4, then what will happen? Then this Wheatstone bridge is balanced. Okay. And if a Wheatstone bridge is balanced, then what is the outcome? Then the outcome is what? If a Wheatstone bridge is in the balanced condition, then there will be no current flowing through what? That bridge resistor. Bridge resistor, which resistor? The R5. R5 will be called as what? The bridge resistor. Okay. Then what will happen? Then no current will flow through. Okay. No current will flow through R5. Okay. But for this thing to happen, this Wheatstone bridge to be balanced, what is the condition needed? The simple condition needed is what? R1 R2 ratio must be equal to R3 R4 ratio. Okay. If that ratio is maintained, then no current will flow through the R5. Okay. And if there is no current flowing through the R5, we will call this bridge is in the balanced condition. Okay. Okay, no current will flow through R5, and Wheatstone bridge, okay, bridge will be in which condition? Will be in the balanced condition. Okay, clear. Now this condition, we use it in many experiment, right? One of the experiment is called meter bridge experiment. Okay, what is one of the experiment? One of the experiment is called as the meter bridge experiment, where we use the condition of what? Balanced wheat stone bridge. Okay, what is the other one of the uh, experiment where we use the condition of balanced V-test bridge? So we use the condition, this balanced V-test bridge condition in the meter bridge experiment. Okay. So meter bridge experiment, what happened? It is an experiment used to determine the unknown resistance. Okay. How do we use the balanced V-test bridge condition? Another application is the potentiometer experiment, isn't it? So these are some of the experiment, okay, where we use the condition of what? The balanced V-test bridge, okay, in the experiment. Okay. So let's see what is the meter bridge experiment. Okay. So meter bridge experiment means what? In a meter bridge experiment, what we do? See, in the meter bridge experiment, what we do? There are two slots. Okay, two slots are there. When you will go to the lab, you will find out there are two slots are there. Okay, and below what will happen? Below you will find out there is a wire there. Generally, chromium wires are there. Okay, generally, what kind of wires are there? A chromium wire is there, and these two slots will be there. In these two slots, what will happen? In one slot, you will keep a resistance whose value is known to you, and in the other slot, what you will do? You will keep a resistance which is unknown, which you have to calculate it. Okay, this unknown resistance we have to calculate it. This meter bridge experiment is only for what purpose? For finding the unknown resistance. And what we do, this branch is connected through a galvanometer. Galvanometer we will discuss in detail. Galvanometer, simply you should understand. Galvanometer is a device which detects the flow of current. Matlab, when the galvanometer is a kind of device, okay? So when current will flow through galvanometer, what will happen? Its needle will show some deflection, that how much current is flowing. And galvanometer can detect a very small amount of current. It's a very sensitive instrument. Okay, so we connect it here like this, and this part of the galvanometer, one part is fixed. Okay, one part is fixed and the other part is what? Movable, which you can move it on the wire. And this whole arrangement is connected by what? A battery. Now tell me what is going to happen. See, when the current will start flowing through this battery, current will reach here, isn't it? When this current will reach here, current will go through this branch, current will go through this branch. After that, what will happen? After again at this green junction, what will happen? Current will reach here and it will distribute into another two branches, right? And here also current can distribute in the two branches like that. So if you see, and this AB wire is what? This AB wire is called the meter bridge wire. Okay, it is generally made of what? A uniform material. Okay, generally these, the material we are using in this wire is nichrome or chromium is there. Why? Because they have very low temperature coefficient of resistance. So at high temperature also, what happen? Their resistance doesn't change much. So that's why we use the chromium wire or nichrome wire. Okay. Now tell me, AB is what? AB is a wire which has some resistance. But one thing about AB wire is what? AB is what? A wire having uniform resistance. A wire having what kind of resistance? Uniform resistance. So now tell me what will happen. Some current will flow through the galvanometer, isn't it? Current will be in all the branches. But if this movable jockey, what we have, we call as what? We call this as the movable jockey. So if we adjust this movable jockey, then can I say I am going to get a point? Then can I say I am going to get a point where that point will be called as the null point. See, if I change the location of this other end of the galvanometer, which is not fixed one, then what will happen? Current through galvanometer will change. But after some time, I will achieve a point which is called a null point. Null point means what? Null point means galvanometer current is zero. Now think about it. When the galvanometer current will be zero, so that is only possible for galvanometer current to become zero if this circuit is in what condition? This circuit is in the balanced Wheatstone bridge condition, isn't it? It's only possible for the galvanometer to show zero current when this circuit is in what condition? It is in the balanced Wheatstone bridge condition. Understood? The balanced Wheatstone bridge condition means what? Can I say this null point is, let's say, something n? So can I say here resistance R by unknown resistance X, should it be equal to resistance of an part, right, divided by resistance of NB part? Now you see this meter bridge wire is made of what? Uniform material, na? The uniform material means what? The resistance of this AB wire is uniform. Area is also uniform. Material is also uniform. So resistance will be also uniform. So can I say that? Let's say this total length of the wire is what? 1 meter. What is the length of AB? Length of AB is what? 1 meter exactly. That's why this experiment is called as what? Meter bridge experiment, because the length of wire we consider here, length of AB wire we consider here is the 1 meter. Okay, that's why this experiment is called as the meter bridge experiment. Okay, so length of this wire is how much? 1 meter. So can I say that if what is the resistance of AN and NB? So you see, can I say L length has capital L length has something resistance, है ना? L length has some resistance R. The unit length will have what resistance? R by L. So AN length will have what resistance? Can I say R by L into length of AN? And same way, NB length will have what resistance? R by L into length of NB. So that's why, can I modify this equation into something different form? R by X equal to resistance of AN, will it become equal to length of AN? Check it. And resistance of NB, will it become length of NB? And generally this total AB is 1 meter. 1 meter means 100 centimeter. So you can also write it R by X equal to, let's say AN length is X centimeter. Okay. So NB length will become what? 100 minus X centimeter. Understood? So with the help of this experiment, we can find out what is this unknown resistance. Here X is what? X is the unknown resistance we want to find. Unknown resistance in this question. Okay. R is what? The known resistance. Understood? So if one of the resistance is known to me in the question, the other unknown resistance we can calculate. calculate it. Is that clear? How do we calculate in this experiment? So in this experiment, what we will do, we will adjust the movable part of the galvanometer in such a way that after reaching a particular point on the wire, the galvanometer stop showing any deflection, or galvanometer stop showing any current flowing through it. The moment I got that point, I will understand that now this circuit has reached which condition? This circuit has reached the balanced Wheatstone bridge condition. And once it reaches the balanced Wheatstone bridge condition, the condition is what? R1 by R2 should be equal to R3 by R4. This is the condition of what? This is the condition of the balanced Wheatstone bridge. Okay, what is this condition? This is the condition of balanced Wheatstone bridge. Understood? So please tell me, understood what we discussed up to this? So next class we will discuss some examples on that. Okay, and we'll discuss about the combination of cell also. Right now we discussed about the condition of what? Condition of the combination of resistance we have discussed. Okay, we have to discuss about the combination of the cell as well. Series and parallel combination of the cell also we need to discuss. So please tell me, clear up to this what we have discussed,
Yes, sir.
right? So
Yes, sir.
chaliye, tomorrow we will have the class at the same 8 p.m. Okay na? And after that you will have the break for your Pongal holidays. Okay, so let's join it tomorrow, right now. 13 to
Okay.
16 we will not have the classes. Okay, right?
Thank you, sir.
Yeah, tell me.